Welcome to the Chapter 5.2b lesson video. We're going to be talking about inverse of a function. So this is a lesson that you probably heard a little bit about before in a previous math class, but we're going to go into it a little bit more with our newer topics. So the first couple slides might seem like some review, but then with a lot of the additional information we've gained in Math 3, there's some newer types of problems that we're going to want to review and look at, okay? So we're talking about inverses of functions, okay? So we can find the inverse of a function algebraically. That's really the goal of today. We will touch a little bit at the end about graphically what it means to have an inverse function, but it's really not that big of a deal as far as difficulty to understand. Okay, so let's go ahead and begin. So an inverse is the process of working backwards to return to the original state. Okay, now in a kind of real world scenario, if we were talking about something like this, if you were to give someone a present, you'd put the present in a box, you would close the box, you would wrap the box, and you would give them the box. The inverse of that process to return to the original state is they would take the box, they would unwrap the box, they would open the box, and they would take it out of the box. Right? So that's the idea. It's the process where everything is opposite, but also done in a reverse order. Okay, so mathematically, that's kind of like saying if I have x and I multiply by 2 and subtract 3, the inverse process to that would be to have x to add 3 and then divide by 2. So we're doing the opposite thing in reverse order. So on this side, x, order of operations first is multiplied by 2 and then subtracted 3. The inverse of that would be to add 3 and then divide by 2. So you undo the subtraction with the addition and the multiplication with division. And that's kind of the extent of what you guys probably know from before, and maybe an example like this next one. Okay, algebraically, to find the inverse, what we're going to do is we're going to first replace the f of x with a y, just to make it easier to work with and less to write. Then what you're doing is you're switching your x and y values. In other words, you're switching your inputs and your outputs. So that way your outputs become your inputs and your inputs become your outputs. So they just switch places. Anywhere there's an x, you change it to a y. Anywhere there's a y, you change it to an x. Well, now now the equation's not going to be the way we want it, so we're going to solve for y. So you're going to move stuff around using algebra to solve for y. And then the last thing you're going to do is replace that y with an f inverse of x. So you write f -1 of x, and this is just to note that it's the inverse of that original f of x. All right, so let's go ahead and do that. So first thing I'm going to do is I'm going to replace the f of x with a y. I'm going to keep it in this red color. Equals -2, and then x I'm going to put in this blue color, plus 4. All right, so that's my step 1. I changed the f of x to y just so it's less to write. Now what I'm going to do is I'm going to switch my x for my y and my y for my x. So anywhere there's a y, I'm going to turn it into an x. And anywhere where there's an x, I'm going to turn it into a y. Everything else stays the same, equals -2 and plus 4, that all stays the same. All right, cool. We now have an inverse function here, but unfortunately it's solved for x, and we don't really like things solved for x, so we're going to solve it for a y. Okay, so to get y by itself, I have y times -2 and plus 4. I'm going to start moving some stuff around. I'm going to subtract the 4 over, so I get x minus 4 equals -2y. And then I'm going to divide both sides by -2. So I will get x minus 4 over -2 equals y. Awesome. And at this point, that's good enough. I can go ahead and leave it like that. I don't have to divide both those pieces by the -2 or really distribute. You can if you want, but that's good enough. And so our final step is to put it back as a function. Originally, the original function was f of x. So we're going to rewrite it as f inverse of x. So y becomes f inverse of x equals x minus 4 over -2. There we go. That's our inverse function. Now, this is a pretty simple example of finding the inverse. Nothing too challenging about that. We're going to try some other ones here. I got 3 of them that we're going to do, and they are a little trickier. They're using some of our newer math that we've learned this year to find inverses, things like logs and exponentials and rationals. And some of them are easier, some of them harder, but let's go ahead and give it a try. Okay, so we'll do these 3. I'll start with this one on the top left, and hopefully I left myself enough room to do these, but let's give it a try. So first things first, I'm going to change that f of x into a y equals the ln of x plus 3 minus 2. Then my x becomes a y and my y becomes an x, so this becomes x equals the ln of y plus 3 minus 2. And I got to get y by itself, so I got to do everything to undo and get the y by itself. So I'm going to add a 2 over, so it becomes x plus 2 equals the ln of y plus 3. All right, now I got to get the ln, that's the outermost piece, so I got to get that away. So I'm going to use the e, a base of e for an exponential. So I'm going to raise both sides from a base of e. That'll get rid of the e and the ln there, so I'll get e to the x plus 2 equals y plus 3. And I'm going to subtract the 3 over. The subtraction 3 is going to go on the lower level with the e. So I'll get e to the x plus 2 minus 3 equals y, but rather than y, I'll rewrite this as f inverse of x. So I'll write f inverse of x because the y is all by itself. And there we go. That is the inverse function of what we originally had. The inverse function of x plus 3 natural log minus 2 is x plus 2 to the e power, or the e power to that minus 3. All right, let's try this top right one. So this top right one, once again, we're going to go ahead and we're going to rewrite this as a y equals 7 to the 2x. All right, we're going to switch the x and the y. So we're going to go ahead and say x equals 7 to the 2y. All right, now this is a little tricky here. So I need to get this out of an exponential. There's a handful of ways we can try and tackle this, but maybe the easiest way to tackle this would be to just take the log base 7 of each side. If I take the log base 7 of each side, log base 7 of x equals log base 7 of 7 to the 2y. One of the things that we've learned is the log base 7 and the 7 cancel each other out. Now that might not be how we would have solved this if we were solving for x, so keep that in mind, it's a little bit different. But yeah, so that leaves us with log base 7 of x equals 2y. And then I want to get the y by itself, so I'll divide both sides by 2. So I will get log base 7 of x over 2 equals y is by itself, so I'll change it back to f inverse of x. Now if it's something other than f of x, if it's like g of x, you would just write g inverse. So whatever letter it was at the start of the problem, you just copy that letter. All right, and then our last one here, f of x equals x plus 3 over x minus 2. This one is a little trickier. This is not something from this chapter. This is rational equations. And so we'll do this one, and we'll see, hopefully it goes okay, goes smoothly. So we'll change that f of x into a y equals x plus 3 over x minus 2. All right, so take your time with me on this one. So all my x's become y's and all my y's become x's. So I'm going to make this x equals y plus 3 over y minus 2. All right, I need to get the fraction. I need to make the fraction go away. So I'm going to multiply that y minus 2 to the other side. I'm going to get x times y minus 2 equals y plus 3. All right, I got to distribute that x out. So I'll distribute that x out, and I will get x, y minus 2x equals y plus 3. All right, now here's the tricky part. I'm solving for y, and I got a couple different things with y involved. So I'm going to rearrange it so all the y stuff is on the left side, and all the non-y stuff, so like the x, the negative 2x, and the 3 is on the other side. So what that involves me doing, that involves me subtracting this y to this side and adding the 2x to this side. So I'll get something like this. I'll get x, y minus y equals 2x plus 3. So I just subtracted the y to the other side and the added the 2x to the other side, so I kind of switched those places. Now what I can do, and this is a little tricky for people to see sometimes, is I can see that, hey, these both have a y. That means y is a common factor. And this is one we'll practice some more in class, but we'll pull that y out times x minus 1 equals 2x plus 3. And now to get the y by itself, I can divide the x minus 1 over to the other side. So the y will be by itself. So I can turn it back into the f inverse of x equals 2x plus 3 over that x minus 1. So what I did there is now that the y was factored out as a common factor, this x minus 1 can get divided back over, which would leave the y by itself. This is our final answer. We now found the inverse. All right, we'll practice some more of these in class. The homework has a variety of these different types of one on there, some easier, some harder, but it's definitely something that with practice I think you can all manage. All right, one more thing that we need to talk about. All right, so graphically, when you're finding the inverse of something, what you're doing is you're swapping the x and the y value. So in other words, your inputs are becoming your outputs, and your outputs are becoming your inputs. So if we were to just quickly graph ln x, there's no shift. My critical point's up 1. It kind of looks like this, right? Something kind of like that. A little rough sketch there. Well, what happens when you do this is the inverse function, it gets flipped over the diagonal of x equals y. So that diagonal is this line right here. So we kind of get reflected, if you guys remember that word from geometry, it gets reflected across that line. And the reason that is because your x values become your y values and your y values become your x values. So this point right here, 0, 1, switch the 0 and the 1. Instead of 0, 1, it's now 1, 0. And that's why our exponential graphs and our log graphs kind of look like sideways versions of each other, because all the x and y points were just flipped. They're the same points, 0, 1, I don't know, this is about 1, 2, this one is about 2, 1, right? The x and y points are just getting flipped. They're getting switched back and forth, and it creates this kind of mirror image across the diagonal. Okay, so graphically, an inverse is reflected across the line x equals y. So that's something you can see there. It's graphed diagonally and it's reflected across that. But really the easiest way to do is to just flip your x and y values. So a point that was originally at something like 0, 1 is now at 1, 0. And that's what makes graphs visually inverses of each other. All right, with that information, you have enough to be able to get started on the homework. If you have any questions, please feel free to reach out. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.